uncaught exception handler. Okay, the third group is implementing the interface called uncaught exception handler and has a method called uncaught exception. Okay, uncaught exceptional handler interface has a method called uncaught exception. This method uncaught exception will be invoked when a thread terminates because of an exception. So when the thread terminates because of an exception, okay, this method is invoked. In this method, the thread which has terminated, so the thread object will be given, and the throwable object which was not caught by the thread, fine, within the thread. Okay, so these two objects are made available to the uncaught exception. So basically the uncaught exception handler is about handling a thread termination because of an exception. Okay, a thread terminates either with exception or it has completed successfully. So if it's just completing successfully, there's nothing like there's no action to be taken. Okay, it has completed the job. But in case a thread terminates because of an exception, okay, and in that case the uncaught exception method is getting invoked. Right? So how this uncaught exception is getting invoked? Fine. Maybe even to try to remember the mechanism which is available here. Okay, we can relate it to what we have, some kind of a example from the real world. Okay, fine. See, we equated a thread to a person, right? We said, okay, person is like a thread, right? So fine, because a person does a job, right? One job at a time. He's just working on one thing. Okay, fine. So same way, yes, we have the thread object, right? And thread group can be looked at as a community. Okay, thread group is like a community. Threads are like the person, right? Okay, so every person it belongs to some community. Fine. Now, what is this about basically? Okay, so fine. Yesterday, I think we saw a few methods. Okay, I'll show them again. Okay, a method. Right? That towards the end, I had told about a few methods. One pair of method is the set uncaught exception handler and the get uncaught exception handler methods available on the thread object. Okay, as well as we have a set default exception handler and set default uncaught exception handler and a get default uncaught exception handler. Okay, these were the static methods. Static method means that's something which is not for a specific thread object, but for it is available for everyone. Fine. Okay. Right. Now, just think like this, right? See, in real world, what would happen if a person, fine, a person dies, fine? What do we do? What is the action to be taken? Right? So, what we normally will have to do is, yes, if this person has a will, right? If there is a will for the person, fine, you do the things according to the will. Okay, that is, if a thread object has got a uncaught exception handler, fine, if you have set the uncaught exception handler, fine, using the set uncaught exception handler, then that uncaught exception handler's method will be used, fine, will be executed, fine, execute that method, fine. But suppose the uncaught exception handler has not been set, fine, it's like the person does not have a will, okay, he's not created a will, okay, then what do we do? Yeah. Okay, so then what is the action to be taken if the uncaught exception handler is not set on a thread object? Okay, fine. So in that case, you have to go by the default uncaught exception handler. Okay. Fine. It is like, okay, you have a uniform civil code. Fine. in that case, you go according to the law. Fine. The law is saying, okay, what should be done? First preference is always the will. Second will be go by the law. Okay. But in absence of any such law, okay, fine, there is no such law. See, static method applicable to all. And it's like a law. Okay. And in absence of such a thing, fine, then what do? Then, oh, the community has something. Okay. Do the last things according to the community. And it depends on the community. That's where the thread group has the uncaught exception method. Okay. And so first preference, see, when a thread will terminate, it will check whether on this thread object uncaught exception handler has been set, right? If it has been set, okay, use the uncaught exception method over there. Fine. The uncaught exception handler is null because you didn't call that method on this particular thread object, fine, which has terminated because of exception. In that case, fine, check if the static method was used. There is a default uncaught exception handler. Default uncaught exception handler by default is null. It's not been set. So if someone has used that method in the JVM, okay, so a default uncaught exception handler has been set. In such a case, use the uncaught exception method over there. Okay, fine. If that is not found, if that is also null, anyway, this thread belongs to a thread group. Okay, the thread belongs to a thread group. Then use the uncaught exception method on the thread group. Thread group is implementing the uncaught exception. Okay, so thread group implements the uncaught exception handler. Right? So that's just so that you can relate and remember the sequence. Okay. Fine. So, fine. So that was about the uncaught exception handler. Fine. Okay. The default uncaught exception handler is to do that is the default. When I'm saying, I'm talking about the thread group class. In the thread group class, the implementation which is available for the uncaught exception method is simply doing a print stack trace on the throwable object. Fine. The thread and throwable both are available. Okay. Fine. So yeah. So any questions? So this was yesterday's thing. Yeah. So any questions now you have so far? Okay, fine. So then we proceed with the some more discussion on the. I think there are just a few more things maybe on the thread group. Okay, I think yeah. Okay, see, thread group is giving us a hierarchy, right? Tree structure. Okay, it's something like this. You have a thread group here. Okay, this normally what we have found is a system thread group, okay, under which we have a main thread group. Okay. Fine. The max priority setting is 10. That's fine. Okay. In both cases, and someone can create a new thread group. So yeah, and we have our main thread over here, right? This is the main thread is under belonging to the main thread group. Okay, well, that's execution of main method. Now related some other thread groups, some other threads which are there, okay, which are more for some finalizer and some such things, and they fine. So you will find here the priority are 8, 9, 10, those kind of priorities. Fine. Very high priority for these kind of threads, whereas the main thread is coming with the priority of 5. So this one is the norm priority initially. Okay, and so main is executing with the normal priority, and subsequent things can be done, right? Okay. Yeah. So now a few more methods which are more from structural point of view available in a thread group is, you might like to know how many threads are active under a particular thread group. Okay, so thread group has such methods where we can find out how many active threads are there. Fine. Also, you can get those active threads. Anyway, a better mechanism is to use the get all stack traces. Fine. There we know we have a mechanism to get all the thread objects, and once you have all the thread objects, fine, you can get that set of all the active thread objects. Right, you should be able to group them. You may use the stream API there. Okay, and you can maybe filter out by a particular thread group. Okay, they're belonging to a particular thread group, and that may be a better way of doing it. But anyway, many of those methods were added when this stream wasn't there earlier. Stream API wasn't there earlier. Okay, so just a few methods. I don't think they would be of much use, but still, yeah, we can list them out. Okay, some of the methods related to the thread group. Okay, and because a similar set of some static methods also exist on those lines, even in the thread class. Okay, but we would not be using it most of the time. Yeah. Okay, but just okay. So for example, okay. Fine. So we have some more methods of the thread group here, and you would have some methods like this. Okay, so we have a method to say active count. Okay, so that returns an estimate of how many threads are currently active. Fine. So when we invoke it on a thread group, so for that thread group, fine, recursively, you can say, I mean, even a sub thread group, a child thread group, right, it will consider count of all the threads under them. Okay, it's a tree structure. Fine. Another one is public int active group count. Okay, how many thread groups are active? Okay, this is the number of thread groups. Okay, now once you know this, see, it was such a cumbersome way. Okay, fine. What you would have to do if you want those thread objects, or you want all those thread group objects, okay, then we would have to use a method which again returns an int value. Okay, name of the method is enumerate. Okay, where the parameter is a thread array. Okay, fine. So you pass a array here, fine, so that it can fill in this array. So you know, to know the how much array I should allocate to call the enumerate method, that's where we might be using the active count. Fine. So first get the active count, allocate a thread array of that size, and use the enumerate method. In that case, the array will be filled with the active objects, active thread objects. And so it will populate this array and return how many it has filled. Okay, and same way this method is overloaded. You know, you would like to, for example, you might say, okay, I want to know exactly in this particular thread group only, and not the child thread groups. You don't want to include the child thread groups, then this boolean value of false can be used here. Okay, by default it should give you the recurse equal to true. Okay, fine. Same way, this is further overloaded because just like you want to know the threads under a thread group, you might even be interested in fetching the thread group objects. Okay, so even similar thing for the thread group. Okay, so the child thread groups, you want to know the child thread groups of a particular thread group? Yes, you can know that. Okay, but anyway, we have the other thing, and we can take the advantage of the streams. Okay, and you should be able to process the from the get all stack traces. Right? We have seen how to get a set of all the active threads. Okay, and threads, they have the method called get thread group. So you can always go to the group, and then we can do all classification. We know how to deal with streams now. Okay, and so that may be a better mechanism. Okay, this is an old mechanism. If someone wants, yes. So it's so this is something which was there in that thread group. Okay. Fine. Now, based on this, a similar, I might just put a few more methods. Okay. Okay, let's have some more related methods related to this. Okay, so in the thread class also, okay, we have a couple of methods. Public static method, okay, returns int, name of the method is active count. It's a static method. So what is it doing? It's returning the active count of, okay, the current thread's thread group. It's a static method. So whichever thread is calling this method, right? So that thread's thread group will be taken, and it will call the active count on that. Okay. So number of active threads in the current thread's thread group. Okay, and same way, it's only this method, right? I can pick it up from here. Okay, only difference is it has been, it's a static method because it is supposed to be on the current thread's thread group. So from the current thread's thread group, okay, fetch all the thread objects and populate my array. Okay, and so anyway, and so these are some related methods to the active count and enumerate. Okay. Okay, and yeah, okay. We earlier, I think we also looked at. Okay, so now we'll continue with the thread class. Right? Thread group thing is fine. Okay, so some more things in the thread class. One of the things when I was listing those properties. Okay, when I say properties, it is nothing but your pair of get set method. Okay, so what are the properties of a thread? Okay, some may be read only, that is only getting, but some may be get and set both. Okay, so yeah, if I just want to list them, starting with the name, priority, daemon. Okay, when I say, see, if it's a boolean type, we don't use the get, but we use the is in front of it. Okay, so these have a get and set both. Okay, other properties which are read only kind of a thing. So we can say alive, is alive, fine. We have a method called is alive. We have the state, getting the state. Okay, so get state returns a thread dot state object. Fine. We have the stack trace. Okay. Fine. What else? Yeah. So alive, right? Alive and state, that will take care of it. It's running, so alive is true. Is alive. I have written the property name rather than saying method name. Okay. Fine. Okay. For read only, if you want, I can put the method name is alive. That's a method. Okay. Get state. That's a method. Get stack. is. Right? See, these are method names, and these would be the corresponding property. Property name. When we say property, yes, they are the names by making the first letter as lowercase and removing the getter prefix, is or get, right? So that will remove. So clear. Okay. Now there is one more. Okay, one more read-only kind of a property. It's called the ID. Okay. So we do also have a method. Sorry. We also have a method called get ID, and the type is long here. Okay. So every thread, whenever it is created, gets a ID. Okay. Okay. So the method, right? The public method on a thread object returns long. Name of the method is get ID. Okay. Fine. So these are some more properties. Okay. Yeah, we had another method. It's a property in the sense read-only property. There's a read-only method. Yeah. So we have the method called is interrupted. It's a read-only. Setting is through a method called interrupt. Okay. So it's not a get and set. Set interrupted is not there. Okay. Interrupt without parameters, right? Okay. Fine. And interrupted, another method to reset. But I'm just putting, okay, this is also read-only kind of a thing. Okay. Fine. Interrupt we had seen yesterday. Okay. We had seen other methods like join, sleep method. Okay. And so properties is fine. Oh, yeah. We have a few more properties which we just discussed earlier. Okay. We have get and set method for the, I'll put in this category. So it's a get and set. Okay. Uncaught exception handler. It's a get and set both. Right? The type of the parameter is uncaught exception handler. Okay, so we have the method called set uncaught exception handler, get uncaught exception handler. Okay, there is that static method pair also we have seen, but yeah, properties wise, yes, this is get and set both. Okay, fine. So some more methods, few more things here. Okay, I think we can quickly look at the API and find out what are the pending things. There, I know some of the static methods which are remaining here. Okay, and there are some static methods. Okay. Okay. We discussed the states of a thread, right? Okay. What were the states of a thread? Yeah. States were new. Okay. Fine. After new, it became. Okay. So when we say runnable, what does it mean actually? We said it's either. Fine. It's either running or ready. Okay. See, why it is ready and not running? Because no, we have limited number of cores and we have multiple threads which are in runnable state. Right? So it's ready, but it's not actually running. It has not got a core where it can execute it. There is something called scheduling of the threads. Okay, since you have more number of threads, it's assumed you will be having multiple number of threads and your number of cores may be less. Okay, and therefore, fine. There is when someone says runnable, it actually when you say start, what would happen? Does it mean that immediately it starts the execution of all the method? No, it will first have to get scheduled. It needs a CPU. Okay, it needs a core, not CPU exactly. Right? It needs a core to be available so that it can be executed, it can be run. Okay, fine. So we have multiple threads which may be in a ready state. Okay, they are not running, but they are in a ready state. The number of threads which are running at any point of time cannot exceed the number of cores. Okay, fine. So runnable state includes running or ready, and ready to run. Okay, now the scheduling mechanism which is there, right? That scheduling mechanism can be based on uh, it can be a mechanism where it says, fine, I understand that we have IO which is like a waiting state. If you do, if a if a process, if a method is doing some kind of an IO, okay, IO activity, then it has to wait for the IO to finish before it proceeds further, right? Okay, so when it does an IO, when it goes into a waiting state, right? One of the thread goes into a waiting state. What will be done? The other thread, fine, which was in a ready state, becomes running. See, running, we have a fixed number of, we cannot exceed a particular limit. Okay, it's decided by the number of cores you have at any point. Yeah, core. So many core. Your CPU has multiple cores. The core, yeah. So it's that core, number of cores we have. Okay, fine. So that's where the scheduling would come up, right? Right. One of the core has to be executing this method. So this thread is active, right? And I'm saying method here, I mean a particular thread which is executing. And so it cannot exceed the number of cores. Of course, one core would also be used by the OS somewhere, right? So at least one core I think should be available to the OS also, right? Okay, not just your process. So your process cannot take away all the cores. Okay, but one thing here is we have the scheduling mechanism. What it does is, okay, anyone falls into a waiting state, and you go into a waiting state because you call the sleep method or you call any such method which is taken into a waiting state. IO also results in a waiting state. You say read, it's most likely going into a waiting state first. Okay, so when it goes into a waiting state, that thread is actually releasing the code, okay, making it available, and therefore that's the time when the other thread, right, which was in ready state will come into the running state. Okay, so when I'm saying runnable, it has actually two substates, fine. One is ready, other is running. Okay, fine. We can have a look at it something like this. Now, states of a thread again. Okay, I'm just putting them again. Okay, with this kind of a substate also. Okay. So initially, thread is in a new state. Okay, right. Calling start takes it into the, I'll say, ready state. It becomes ready. Okay, from ready, fine. So this is because of the start. From ready, it will go into the running state. Okay, fine. This is by scheduler. We don't have to call a method, right? When see these two combined is basically the runnable state. Okay, that's your runnable. So it's going into running state. In running state, what will happen? One is it can go into a waiting state. From this it might go into, so some method like join or something is called, and so there are several methods which can then take it into the, okay, here I'll include all the three states here. Okay, it may be any of those three. So it's in, so there are three different states where from running it can go into one of those three. Okay, it would be going into a waiting, okay, or a timed waiting, or it might go into a blocked state. Okay, that's basically waiting for something or the other. Fine. And then when that wait finishes, where will it go? It has to go back to the ready state. Okay, when the wait finishes, goes from these three states back to the ready state, ready to running. Okay, now what can happen is, if you have some particular thread which is very CPU intensive, fine, okay, it's not doing any IO, there's no instruction which will ever put it into a waiting or a time waiting or a blocked state. It's not going in that, and it's hogging the CPU. We could say, oh, it has hogged the CPU. Fine, it. So you get that feeling, oh, my system is hanging. Fine. When you see some system is hanging, it's not that actually a hang state. It is basically some particular thread hogging your CPU. Okay, fine. So now when you design your application, you do not want to give such an impression, right? So if you have such a loop, but it would normally, we have loops to do a lot of processing. Okay, so if you are writing such a loop, fine, this is something which is advised, is that yes, you should always check, maybe I have to process thousands of records, right? So after every 1,000 record, maybe I will release the CPU. Okay, so you say, oh, this thread is a cooperative thread. It's cooperating with others. It's not just greedy. Okay. Okay. Fine. So if you are writing such a code where you understand this is going to be CPU intensive, okay, you have in your loop, you can introduce a mechanism where it knowingly would like to release the CPU to give chance to others. Yeah, that's you will have to put that logic when you would like to do it. So it may be a count, right? Number of iterations. After so many iterations, I just want to release the CPU. Into, you would like to put it into, no, okay. Now what, see, now earlier, the API has put one method available to us, which says you will be able to go from running to ready state. Okay, and for that we have a static method called yield. So this is a static method. So we have a static method yield. The idea is going from running state to ready state. Okay, see one thing, how does it schedule from ready state to running? It all depends on priority. When scheduling, okay, what it will look, okay, all those who are in the ready state, which one is the highest priority? That only I will take. That is the scheduling mechanism. Okay, other things, yes, maybe it might, oh, when it is the priority is equal for multiple threads which are with the highest priority, okay, then maybe who is waiting the longest, maybe that may be given the, who has been waiting for the longest time, that may be given a priority here. Okay, when equal priority is there, then some other criteria may be used. But priority, higher priority, unless it has finished, lower priority will not be taken up. Okay, so meaning of priority, I think you can now know from here how it affects. Okay, yeah, and then finally from running state, when it finishes, it has to go into the terminated. Okay, fine. So that's how the states of a thread will be. Okay, see, for going from running to this, there are several things, right? Like sleep, join. Okay, these are a couple of methods we have seen in the thread class. Okay, later you will also be discussing a method called wait, which is a method of the object class. Wait is a method in the object class, available on all objects. Okay, right? But invoking a thread invokes a method called wait. Oh, it's going to go in a waiting or a timed waiting. Fine, states of a thread are like this. Fine. Okay, so this is the runnable. Fine, this is new, runnable, and then those three states, and then the terminated state. Okay. Yield method, yeah. It will just put from running to ready state. But now what has been, what we normally do, we don't rely on that much. Okay, that method says, okay, you need not rely on this now. Okay, what we normally will do is we'll just say sleep and maybe just a few milliseconds. Okay, sleep 10 milliseconds. Okay, that's fine. So that's coming out of the, so you might just say sleep 10 and then it will go into a waiting state, from there to the ready state. 10 milliseconds, yeah. Yeah. No parameters. Huh. So you can decide. Yeah, you can even say yield 2 also. Not yield, sleep 2. That's also fine. Thread dot sleep. Something, some value must be there. Fine. So we can have a look at the, okay, some more methods, and yeah. Okay, then we can talk about, okay. Okay, so new runnable, fine. So runnable is actually having running and ready states, and that should be clear. The other states from here, so from here to, okay, I can just put it like this. How do I put a down arrow? I don't know. Anyway. Okay, so from runnable to this, and okay, and yeah, from runnable it can be either going to the one of the, so it's one of waiting or timed underscore waiting, or it will be a blocked state. Okay, and from here it will have to go back to the runnable. Right? All these three will take you back to the runnable only. Right? And then runnable can then ultimately take you to the terminated. From terminated, there's no going back. Okay, fine. So new and terminated. Fine. New has only one way. It's only going to go to the runnable. From runnable between all of those three, I think this should be a separate line, but the line has to be from runnable to this. So terminated only from runnable. Okay, so states of a thread. Fine. Any questions?